Greetings, Earthlings. Today we attempt to answer the question, what is more cool than a 4.5-digit Nixie tube multimeter? Like the Keithley 171 that we see here and saw in previous videos. Well, how about a 5.5-digit Nixie tube multimeter? This is a Keithley 190 digital multimeter. It's 5.5 digits. Let's see, specs on it. 90-day spec on DC volts, 0.015%, 0.3% AC, and it claims RMS, and 0.02% on ohms resistance. Basic accuracy. Okay. This particular one was sold as not working, does not power on. And you can see it has some issues. This is how it came. And it's got some buttons stuck in here. And so the buttons are not very responsive. That'll need some probably deoxit. I'm hoping we'll clean those up. These are just stiff and yeah, not very responsive again. That's the power switch right there, and just reading rate. It came without a fuse holder, without a fuse and without a fuse knob, cap, whatever you call that thing, which makes me concerned that maybe it's blowing fuses. I don't know. We'll see. So we'll open this thing up and have a look, poke around before we go and start. I don't have. It takes a 1/4 amp fuse. I don't have any fuse that I could put in there or a holder. So I'm gonna have to order those things. So we'll have to. We'll just go through it in this video and see what we can see. I also got, you can see that, a printed manual for it. There's scanned manuals online, but the schematic scans in those are just horrible, unreadable, illegible. So I got a printed manual so I can actually see the schematics. All right, so let's take a look at this. There's 2 screws on the top. The top cover should slide off. On the bottom, there's a screw missing. So there should be 2 screws here. There's 1 screw. There's a rubber foot. If those are, yeah, those were rubber. Kind of petrified rubber, but there's 1 missing. But I don't think that's going to cause us any grief. So let's look inside. Okay. There's another board underneath, so we're only seeing 1 board here. That's not the whole thing, but here's the power supply here. I have to check those caps. Transformer, okay, we're going to check, well, this looks like the power switch coming here. Why is it disconnected? Where does that go to? Oh, right there. Okay. It goes right there. We'll see if maybe that's part of the problem. It could be an easy fix. I don't know. On the bottom. Let's have a look. It's a little stiff, but it's moving. There it goes. Okay. Nice shield there. And here's the, this looks like the analog board. Capacitor, oh wait. Here's our, it's probably the integrator capacitor here. Here's all the adjustments. There's a bunch of them. Here are the switches. Let's see if I've got access to the back of them. Yeah, so I can spray deoxide in there. So nothing obviously burned. That's a weird looking jumper there. I wonder if that's for calibration or something. I don't know. Nothing obviously burned or anything. We do have the power switch. So I'm gonna bring this meter in because it has a beeper in it. Okay, and nothing, but it's switched off. Switched on, nothing. Well, okay. It looks like the power switch is bad. But I should also check, because there could be other problems. If it was blowing fuses, we could have a bad transformer, which would be a really bad thing, because finding a replacement for that would be hard. Might have to fashion up a new power supply or something rather than oops. Let's see. I'm not even looking at the schematics right now. Okay, this one side of the fuse. This is the other side of the fuse. I think. Doesn't seem to be doing anything. Oh, that shouldn't matter. Because that's way out of the circuit. But one side, I would think one side of that power line comes into oh, there it is. Okay. So that side goes to the power switch. Goes off and comes back. The other side probably goes directly to one of the transformer windings. Yeah. There's a fuse. This is a 1 amp slow blow, but I'm just going to stick it in there. That'll give me something to connect to anyway. Okay, and I was looking over here, huh? Ha! It's a black lead, and it comes to... Well, yeah, okay, that kind of makes sense, doesn't it? Duh. Don't try this at home, folks. It requires a certain level of intelligence that I don't seem to have. Okay. There's that. Okay. The other side would go to the transformer. The other side of this thing, okay, would go to the transformer winding directly. Let's see. Wait, which one was which now? That's that. Okay, so here, this should go to one of these transformers. Okay, right there. Okay, good. Beep, 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 beep. Why is that saying max? Must have pressed that button. Okay. You see that? Oh, let's say that. Okay, transformer in. Okay, so power supply, it goes through the fuse, goes through the switch. And then through this selector switch to one side of the transformer, and then these are either put in series or parallel, it looks like. So anyway, from that pin to there, so one of these pins, I just I was going to here, and one of these, yeah, well that says 0. Let me see. Let me measure inductance. See if there's any inductance there. How's that? One microfarad? Microfarad? I said inductance. And, oh wait, and first of all, okay, so let's see if there's any inductance. We got this set, well, it's on the 2 Henry scale. It's fine for now. Did I do that right? Oh, yeah, there was something there. It's there and then it's not there. It's there and then it's not there. This side goes nowhere. So I don't know. I don't know what I'm seeing. I think maybe the transformer is there, that primary windings exist. On the secondary, transformer secondary, definitely want to check. Well, I want to check on the voltage rails to see if there's any short there. If this has like tantalum capacitors across the voltage rails, tantalum capacitors have a habit of kind of, if they're abused, blowing up and failing as a dead short circuit. So I want to see if I can find the rails and if it looks like a short circuit out of that. Okay. So test point 8 is plus 15. Test point 10 is minus 15. And test point 7 is plus 5. Okay. Where are these test points? I see, stand this up. I see something there, there, but they're not labeled. Turning it around. Something there. But again, not labeled that I can see. So, again, we go to the manual. There is nothing in the manual that points out where those test points are. Okay? This, Keithley's manuals, I'm going to say, are crap compared to Fluke, for example. All right, I'm seeing some op amps here, and I know that LM301s. I know that pins 4 and 7 of the op amp have the plus and minus rails. So I'm going to use the input low as one side and test those. Okay, they look fine. They do not appear to be shorted. Okay, plus 5. If there's digital logic, I can measure between. What was that? I can measure between pins, the corner pins. Here's some counters. Actually, those are 7490s, which might be different. Yeah, that's fine. Okay. Okay. So we do not appear to have a short circuit across any of the voltage rails. We do appear to have a bad on-off switch. These switches are bad. I'm going to address those right now. And we need a fuse holder. I'll check the capacitors. I'll check them in circuit. And I may just replace them anyway due to age. How old is this, you ask? 1975. I mean, the date codes vary, but I see 7541. Oh, 7618. So either that's been replaced or this was built probably in 1976. Mid-1976. There's 7520, 7425, 7541. So, I mean, the date codes are kind of all over. 7502 on the LM309K. Date codes are kind of mostly in the 1975 range. But some 74s. So we're going to say 1975, 76, which is quite a few years. Well, wait, 77 on the bottom here on these op amps. 7629. That's interesting. Maybe they didn't 75 on these precision resistors. Maybe they didn't sell a lot of these things. Maybe it's been serviced previously. I don't know. Okay, so I'll get on the switches. The other thing I'm going to do is I'm going to figure out where the test points are, and I'm going to mark them on the not the schematics, but the layouts. I mean, so it has on one side of the page. Right, it has a schematic. Well, no, I mean, there's a board layout right there. And so I'll figure out where the test points are and actually mark them on here, write it on there, so that I will know. And then we'll proceed from there.